All right, today we're looking at Unit 2, Lesson 11, and we're going to be finding where graphs intersect each other, or where equations would meet, okay? Or where we might say where we find common solutions to the same equation. So it says mentally identify a point where the graphs of the two functions intersect if one exists. They may not exist at all, okay? So if we think this through, okay, we got f of x equals x. So that means the x and the y are the same amount, okay? And on the other equation, g of x equals 3. Well, I'm thinking there, okay, based on what we know, if g of x equals 3, that's the same thing as saying y equals 3. So the y value is always 3. Well, if this y value is 3, then the x value must also be 3. So I think those intersect at the point 3, 3. Okay, so we're connecting what we already know about graphing, just looking at two graphs at the same time. So on this next one, we've got j of x equals x plus 3x minus 3, and k of x equals 0. Well, if k of x equals 0, okay, we're looking at when y equals 0. Well, we know these are both intercepts. So we must be talking about the point 3, 0, and negative 3, 0. From the second one, we get negative or positive 3, 0. From this first one, we get negative 3, 0. Okay, because if either of those gave us as equaled 0, then the whole thing would equal 0. So it'd be equal to the other equation. Now this next one, that's not quite so easy. Okay, so I might have to come up with another way there. Okay, I know this one is going to cross, this one's got going to cross the y-axis at negative 3. Okay, so if I put in a positive 3, this equals 0. So 3, 0 would work there. Well, same thing here. Okay, this would equal 0 at positive 3, 0. Okay, and we're going to dig deeper in that one. Okay, and this last one, I don't see any similarities at all. This is going to cross, the function p is going to cross the y or the x-axis at negative 5 and positive 5. The function q is going to cross at negative 3 and positive 3. I don't think there is one. I don't think there's an intersection there. All right, so a couple ways we can come up with those. Okay. All right, so activity 2, it says for each pair of polynomials given, find all the points of intersections of their graph. Okay, so a couple ways I could do this. One, I could just graph them and use graphing software to help me out. So we're going to start with that. We're going to try that. So let me switch to graphing software. The first equation was c of x equals x squared plus 7. X squared plus 7. So I got that one. The next one is d of x equals 2. So d of x equals 2. Well, that should have been minus 7. I messed up there. That'll help. All right, so I can see they cross in two places. Positive 3, 2 and negative 3, 2. Okay, so I can write those down. I got positive 3, 2 and negative 3, 2. Okay, so one way to solve that would be to use graphing to help me out. Okay, now I could do this algebraically. I could actually set these two equations equal to each other. I could say x squared minus 7 equals 2. So I could add the 7. And I could say x squared equals a positive 9. If I take the square root of both sides, I've got x equals plus or minus 3. That means I really have two answers. I've got x equals positive 3 or negative 3. Okay, well, I know that y always equals 2. Okay, so I've got positive 3, 2 and negative 3, 2. That would be one way to get it. Or I could plug these x values into the function c. So 3 squared would be 9, minus 7 would give me 2. Negative 3 squared would be positive 9, minus 7 would still be 2. Okay, so a couple ways to do that. Okay, kind of like the graphing method. Okay, all I got to do is punch it in and see where they cross. Okay, on this next one, okay, I could use my calculator, or I could use my graphing software. So let me switch again here. Okay, and I've got f of x is x plus 7, x plus 7, and x minus 4. Okay, so there's one of them, and the other one was just x minus 4. I'm going to just copy because I'm being lazy here. Okay, so I've got two solutions. I've got 4, 0 and negative 6, 10. So there's one possibility. Let me switch back out here to this. So I had 4, 0 and negative 6, 10. Now, I expect that 4, 0, because if I plug in 4 here, the function is going to be 0. Okay, or if I plug it in here, okay, since that x minus 4 is in both of these equations, that makes sense to me. So, or I could set them equal to each other. X plus 7 times x minus 4 equals x minus 4. Okay, so I could set this equal to 0. So I'm going to subtract x minus 4 from both sides. So I've got x plus 7, x minus 4 minus x minus 4. Okay. Now this time this gets a little tricky. I'm going to factor this x minus 4 off of this, and I've got x minus 4. Now if I take the x minus 4 off of the first one, I'm left with x plus 7. So I'm left with x plus 7. And then if I factor off the x minus 4 from the second one, I totally take it out. So I've got to hold that place. So I've just got minus 1. So I've got x minus 4 times x plus 6 equals 0. Well, I know that gives me x equals, add that 4 to the other side, I get positive 4. Subtract that 6 to the other side, I get negative 6. Okay, and then I can plug both of those in. If I plug in positive 4, I'd plug into the g of x function. 4 minus 4 gives me 0. If I plug in the negative 6 minus 4 gives me, that should have been a negative 10. Let me verify that with my graph here. Oh, wrong tab. Sorry, guys. There we go. Yeah, negative 10. Okay. I kind of like the graphing method. I really don't care which one you use. Okay. All right, let's try another one here. So our next one we have is m of x equals x plus 7, x minus 4, and n of x equals 2x plus 5, x minus 4. Okay, so I'm going to say I probably would just graph them. Okay, I don't think it's necessary to do both every time. Okay, that's not the point. The point is pick one and use the one you like. There we go. I keep messing that up. Okay, so we've got x plus 7, x minus 4. They named that m. Really doesn't matter. And the other one they named n of x, and we had, I'm going to stick this in here, we had 2x plus 5 2x plus 5, and x minus 4. Okay, so we're looking for where they cross each other. And it looks to me like I need to zoom in here. Okay, they're really, really close together. Okay, but right there looks like my only intersection. Okay, so I'm going to say 4, 0 is the only place they cross. 4, 0. Okay. All right. This last one, again, I would probably just go with graphing it. Okay, I don't think you have to do anything big here. So we had P of x. P of x is x plus 1, x minus 8. And then we had Q of x is x plus 2 and x minus 4. And let me zoom back out here. And it looks like I only got one intersection at x minus 8. Okay. Yeah, doesn't look like it crosses anywhere else. So one intersection at 0, negative 8. So 0, negative 8. Okay? All right. Whole point there is there's really two ways to do it. You can either set the equations equal to each other, okay, and solve it, or you can, okay, or you can graph it and solve that way. Okay? All right. Now here's another thing I want us to think through. Okay? Last thing, and then I'm going to let you go. Okay, it says consider the functions p of x equals, and you got this big old function, and q of x equals 5, 6, 4, 0. Okay, use graphing technology to find the value that makes the of x that makes p of x equal q of x true. Okay, so I want you to catch this. So I'm going to go graph this. So I have 5x to the third power plus 6x to the second plus 4x. And then I have 5,640. Okay? And we're going to have to zoom way out here. Okay, so they cross way up here. There we go. So that's the point 10, 5,640. So 10, 5,640. Okay, so it says for the x value of the point of intersection, so that's 10, what can you say about the value of 5,640? So if I plug 10 in there, that's what the question is. Well, if I plug 10 in there, we're going to find out that it equals 0. Well, what's that suggest about it being a possible factor? Well, it says that x minus 10 must be a factor of the polynomial. And we're going to work more on that later, but that's just something to kind of keep in mind there. Okay? So if you find where they cross, that x value is going to help you find a factor. All right, good luck on the homework. Let me know if you have problems.